Our goal is to get x by itself, or to solve for x. So in this case, we need to first recognize what's a little strange about it, and that x is on the bottom of the fraction. A little bit strange when something's on the bottom. So the kendama is normally in this position. If we have it on the bottom, then it's a good idea to put it in a way that we can go back to our normal state. And so that's kind of the same idea with this, is we need to get x out of the bottom of the fraction in order to work with it. So the first method that we're going to look at is called clear the fractions. Clear the fractions is a powerful method that can be used in almost any situation, given the context. But in this situation, the key idea here is to multiply by the common denominator. So when we look at these, we're looking at the bottom number. Think of it like you're adding or subtracting the fractions. What bottom number can we have here so that they're both the same? Okay. So if they're both the same, bottom number, we can just do kind of the easy trick, which is multiply them, because we don't know what x is in this case. So we're going to multiply by the common denominator. What we do to one side, we do to the other. So let's go ahead and do that. So what do I multiply both sides by? The denominators, or the bottom of the fractions, multiplied by each other. So on the left side, we're going to multiply by 3x. On the right side, we're going to multiply by 3x. Now remember, this 3x, if we don't see anything above or below it, that really means it's in the top of a fraction. We can almost look at it as over 1 to kind of help us. So what this does is, and the reason why it's called clear the fractions, is in one move, all the fractions are gone. So in this case, we see a 3 is on top here and a 3 is on bottom here. That means they reduce out. And on the left side, what do we have? We have an x times 2. So this is going to be a 2x on the left. The equal sign stays in the middle. And on the right side, what cancels out here? What's in common on the top and on the bottom of the fraction? Hopefully you can see this. There's an x on top and on bottom. Those reduce out. And what do we have left? I'll go ahead and show it. This is all multiply. That's a 5 times 3. Let's go ahead and now finish our work here. I would say simplify first. It's kind of the easiest way to do it. Don't want to skip too many steps. So 2x is equal to 5 times 3 is 15. We want to get x by itself. This one should be a little bit easier for a lot of you. So what keeps x from being by itself? The 2. What's the 2 doing to x? It is multiplying. We do reverse operations to get x by itself. So the opposite of multiply by 2 is to divide by 2. What we do to one side, we have to do to the other to keep things balanced. And the 2's, once again, kind of remind yourself, there's a common 2 on top and bottom here. That means they reduce out. And we have x equals 15 over 2. Now we could make this into a it's already an improper fraction, or a mixed number, or a decimal. But usually, the higher up in math you go, we want to kind of keep these improper fractions if possible. So 15 over 2 is a good answer for our x, and we can always plug it back in to check our work. But for now, how do we solve? This is clear the fractions. The next method we will look at is the reciprocal method. And in this case, there's a couple different versions of the reciprocal method. We're going to focus first on the flip both sides method of reciprocal. Well, reciprocal means flip. And what you do to one side, you have to do to the other. So in this case, it's a real shortcut, straightforward way of getting x out of the bottom. Now, kind of the key here is that you can only have one term on each side of the equal sign, which we have in this case. So if I flip both sides, once again, we're kind of recognizing x is on the bottom here. That's kind of makes trouble for us. So we're trying to flip it or change it in such a way that x is no longer on the bottom. So if I flip both sides, what is that going to look like? Well, the 2 over 3 changes to a 3 over 2. The 5 over x changes to an x over 5. Okay? Recognize x is no longer on the bottom of the fraction. That means it's not trapped anymore. So in this case, we're trying to get x by itself again. Once again, we use reverse operations to get x by itself. So we ask ourselves, what keeps x from being by itself in this case? The 5. What's the 5 doing to it? Well, that fraction bar means it's being divided by 5. X is being divided by 5. What's the opposite of divide by 5? Multiply by 5. So we do that to both sides. So we multiply by 5 on this side, multiply by 5 on this side. And once again, you can remind yourself if you need to, you can put these numbers over 1 to kind of see it a little bit better. All right, so in this case, on the right side, we have a 5 and a 5 cancel. And now we have a number times a fraction, or a 5 over 1 times a fraction. You can think of it a couple different ways. The shortcut is it always multiplies to the top, or our operations on fractions is to multiply straight across. How do we multiply fractions? Straight across. All right, so in this case, that's a 5 times 3 is 15. 1 times 2 is 2, or you could have done that shortcut, 5 times the top of the fraction is 15, and the bottom stays the same. What do we have on the right? The 5's cancel, and we're just left with x. Notice we got our answer again, 15 over 2. Our next method for solving for x when it's on the bottom of a fraction is another reciprocal method, but this is kind of a multiply by the reciprocal. So in this case, this can also be used if you have a fraction that's keeping x from being by itself, but we can also use it to get x out of the bottom of a fraction. Remember, when x is on the bottom, it's kind of trapped there. So here's our technique. To get the x out of the bottom, we can multiply by this reciprocal here. So this is really kind of like the number, we can put a 1 under that, and this is like 5 over 1 times x in this case. So we're going to look at it as flipping it. This is the reciprocal. Remember, what does reciprocal mean? It means flip the fraction. So in this case, if I flip this fraction, whatever this is on the right side, we're going to flip it and then multiply both sides by that. So let's go ahead and do that. So if I flip the 5 over 1x, this is going to be a 1x over 5. And we're multiplying by it. And what we do to one side, we have to do to the other. So this is an x over 5. And I don't need that 1. You can use it if you like it as a placeholder. So how do we multiply fractions? Or what do we do next? Well, let's go ahead and take care of the right first. In this case, the right, the x's are going to cancel. So we got to cancel with the x's. The 5's are going to cancel. This is built to turn into a 1. So notice if everything cancels here, we have a 1 over 1. So that's just equal to 1 on the right. What do we have on the left here? How do we multiply fractions? Straight across. So this is an x times 2, or a 2x. We can put multiplication in any order we want. And what do we do on the bottom? 5 times 3 is our 15. All right, so let's go ahead and use the reciprocal multiply method to both sides again. So in this case, what we have here, this is the same thing as, and this kind of helps, this x is on top, so it's kind of like it's on the side here. That's a 2 over 5, x equals 1, okay? So you can kind of move it out in front if it helps you to see it a little bit better, but you can do it also straight away at this stage either way. So we're going to multiply by the reciprocal to get x by itself. So what am I going to multiply both sides by? The reciprocal of this is 5 over 2. Multiply both sides by that. Oh, sorry, this is a 15. And this is a 15. All right. So we're going to multiply both sides by the reciprocal. We had a 15 on the bottom there. So that means what we do to one side, we do to the other. Let's not forget. So this is a 15 over 2 multiplying by both sides. The 15's cancel on the left. The 2's cancel. Once again, this is built to turn into a 1. And we have x equals, what's 1 times 15 over 2? Keep practicing kind of your laws of fractions, operations on fractions. We're multiplying straight across. We have a 15 on top and a 2 on the bottom. You could have done the same thing right here straight away. Recognize we have a 2 over 15 next to our x. So we're going to multiply by the reciprocal here. That's going to be a 15 over 2. Do that to both sides, 15 over 2. And we have that same result. The 2's cancel, the 15's cancel. 15 over 2 times 1 is just 15 over 2. So either way, this is our next method for solving when x is on the bottom of a fraction. For our next method for solving when x is on the bottom of a fraction, we're going to go ahead and use the cross multiplication method. So this is a special case that we kind of just need to remember it as a trick if we're using this method. So for cross multiplication, it's really important that we recognize it only has one term on the left, one term on the right, and then we're going to just multiply the bottoms straight across or at a diagonal. So for this one, if you don't have a fraction, you need to make sure you change your number into a fraction by putting it over 1. But in this case, we multiply in this way, the x times the 2 and the 3 times the 5. So that's going to give us the 2 times x on the left, equal sign stays in the middle, 3 times 5 on the right. That's going to give us 2x equals 15. And lastly, how do we get x by itself? What keeps x from being by itself? A 2. It's next to it. That means multiply. The opposite of multiply by 2 is to divide by 2, and we need to make sure we remember to do it to both sides. Finally, we'll get the 2's reduce out. X equals 15 over 2. The last way we're going to show is through a matching fractions technique. So we're trying to get these fractions to match or almost match, and once they do, we'll be a little bit closer to getting x by itself or solving for x. So in this case, we can see that there's a 5 keeping this x from being by itself. We're also recognizing x is on the bottom of the fraction. So this can be rewritten as, we have our 2 over 3 on the left equals, now if I move that 5 out in front, that's going to be 1 over x times 5. Okay, so remember a number on top can just be moved out front. You can also verify it by if we put this over 1, that would multiply to the top 5 over x again. So let's get x or as much as we can by itself. So we'll get rid of this divide or this multiply by 5 because this is a multiply by 5 right here. So we'll go ahead and divide by 5. So the 5's will cancel. We'll go ahead and divide by 5 here. So these reduce out. And then we have this a little bit tricky on the left side right here. So the trick is if it's being divided by 5, that's on the bottom. So it's going to go to the bottom also. So this is a 3 times 5. But a lot of times we kind of forget how to deal with these. So here's my recommendation for doing it. We can look at this as another divide sign, this fraction bar right here, or the other one, either one, it doesn't really matter. So I'm going to check this, I'm going to look at this as a divide. So this is a 2 over 3. This fraction bar is a divide by 5. Okay, so all of this is just being rewritten as a fraction bar as a divide sign. And over here on the right, these 5's cancel and we just have the 1 over x. Okay, so how do we divide with fractions? Well, my rule is we can never divide with fractions. We can only multiply, add or subtract. So we have to change this to a multiply problem. So this changes to multiply and that flips the second part. That's how we divide fractions. So that changes to multiply. And then what happens? 1 over 5. This is all equal to 1 over x. Okay? On the right side here, we have a multiply of fractions. Do you remember how to multiply fractions? Okay? We multiply straight across. So in this case, I'm going to let's go ahead and give myself some more room. We got 2 times 1 is 2 on the top. 3 times 5 is 15 on the bottom equals 1 over x. Now, to finish this off, we have to kind of recognize x is on the bottom of the fraction here, and it's just a 1 on top. So this is one of the tricks that we kind of saw earlier, but whenever you have it on the bottom, that's another way of saying reciprocal or flip your fractions. So if it's on the bottom here, that means this one has to be flipped. And the 1's up there, so that's kind of makes it a little easier and more straightforward. So we got a 15 over 2 equals x over 1. We don't need that over 1, So we can just keep it like that. And once again, we have 15 over 2. So several different ways of getting x by itself and solving for x when it's on the bottom of a fraction. I recommend trying to be able to learn all these ways. If you have a mastery of all the ways, then you're more likely to be able to use the most appropriate method at the best time. But at least make sure you can get through and be dependent on at least one method, and that'll give you an advantage of getting through these problems. So which one did you like the best? Go ahead and maybe order these. I would recommend, out of the methods I've shown, the 4 or 5 methods, which one's your favorite to least favorite, so that you can kind of use that to help you organize and be more ready and apt in the future. Good luck.